In this video, I'm going to go over how the board program works, how to launch that based on a schematic. But first I want to take a look at the schematic that we have here. So your schematic should look pretty similar to what is shown here. There may be a couple of minor differences, the way things are placed or located, but overall the schematic should look generally the same. Now I'm going to run the ERC and see what errors we end up with. So it says, first of all, it says power pin IC1, VCC plus connected to 9 volts, VDD to 9 volts, VSS to ground. Those are not really major errors. What that's really showing is that the names of these pins. So for example, if we take a look at IC2, the pin that's supposed to be connected to the positive supply is named VDD, but we're connecting it to 9 volts. And VSS is connected to ground. So that's not an issue. It's just a naming convention that's a little different. And at some point we might go over what these actual terms SS and DD mean. The other errors I'm getting here are part LED 1 through 8 have no values. And that's fine. You could put a value of a color or something, but it's really not necessary. And same thing with the connector. X1 has no value. So connectors don't typically have a value like a resistor does. So what I can do at that point is clear all, and then, or I could approve them. There are a couple different things we can do there, but there were no showstoppers there, so we're going to go ahead and move on. So the first thing I'm going to do here is create a board. And this is just going to be an introduction. There's a lot to board layout that we'll get into over the next few weeks. But I want to kind of just start on the basics of how this works. So don't feel like you have to make it exactly the way I have it or try to do it perfectly. But this is just kind of a starting point. So first of all, up on the top, there's a button here that says Generate Switch to Board. And I'm going to click on that. And it should say it does not exist. It's because we're creating a new board. It says Create from Schematic, so I'll click Yes. And now we've got this big board here. This is this big black box with the yellow outline is the actual board that we're going to be creating. And all these parts are off on the side of the board. You might think, well, that doesn't make sense. Shouldn't it know where they go? And the answer is no. Eagle has no idea. You are designing this board, so it's up to you to figure out where the parts go. Now, for starters in this case, I'm going to move the, click on the Move button and move the two integrated circuits kind of close together here in the middle. That's because the circuit kind of revolves around them. Now, this is a low frequency circuit, so it's really not too critical where the components go. However, you'll notice that this capacitor, these yellow wires that you see, these lines are called air wires. And what they do is they show the electrical connection between the points, but it hasn't actually laid down any of the traces, the actual routing traces. So at first you might think, oh man, everything's, all these things are crossed over each other. It's going to cause a problem. Don't worry about that for now. But where it's helpful, for example, is, the C2, I'll notice that it's connected close to this device. So it doesn't make sense to have it over here. We want to have it so that it's easy for the auto router to run the wires or traces, and I'll explain what an auto router is shortly. So I notice that this is kind of rotated. You'll notice that these two lines cross over. If I right-click twice, then I get kind of what looks like a little bit more logical location for that capacitor. If you're missing that capacitor, don't worry. That one isn't really necessary for the circuit operation, but it shows up from time to time. Now, the next thing I'm going to add on here is this C1, and the reason why, again, is that it's located, you can see that it's got a connection point kind of close to the 555 timer. And the two resistors here, I believe it's, by the way, we can toggle back and forth to the schematic by clicking on the schematic board button up here. So let's take a look at what parts are close by the 555, because we want those parts to be located fairly close to the component. So R1, R2, C1, and C2. We want to get those fairly close to the 555 timer. So I'm going to move R1 over here, just in that general area. And let's see where R2 is. R2 is here. And C1, that should be the polarized capacitor. We've already moved that. and the other capacitor. So those are the main. Let's go back real quick. I thought I was missing something. Nope, that's it. Those 2 resistors and the 2 capacitors. So what I'm going to do now is kind of zoom in here a little bit and see kind of what logically makes sense where to place these. And this is not a hard science. There's no correct way to do this, but there's some general guidelines we want to follow. So if I start to rotate this part, I can kind of see that that top pin on that resistor is fairly close to pin 8 there. And if this one I can see is kind of connected between that resistor and the capacitor. So I'm going to just put them like that. And it doesn't really matter that much. We're not trying to optimize our space so much. We'll talk about that more later on. Now, once those are laid out there, I can click on this button called Rat's Nest. And this is located on the left hand, about in the middle. And if you click on that, what it does is it kind of traces these air wires to approximately where they are going to run the actual wire on the circuit board. And that's sometimes helpful to kind of see where things are. Now, if all of these lines get really messy and it's hard to look at the circuit because of it, if you click up on View, Layer Settings, we can deselect what is layer 19, which are the unrouted layers. And you'll see that those all disappear. And sometimes that's convenient to do when we're just trying to kind of get stuff laid out and kind of clean things up a little bit. For now, I'm going to leave it on there. Okay, so we've got those capacitors or resistors. Now, let's say we want to move all the LEDs in one shot. So what we have to do is we're going to group those parts. I'm going to select Group, left click and drag around all of them. There are a couple ways you can do this. The way I usually do it is hold down the Control button or the Control key on the keyboard, right click. Whoops, that didn't work that time. Oh, I grouped them, but I'm not moving them. Sorry about that. So we want to actually move that also. So if I right click, let's go through and group them again. I'm going to group them. Then I'm going to click on Move, and if you hold down Control and right click, you can move that group. The other way to do that is I can again group them as a group, click Move, and then if you right click in the group, it'll say Move Group. That's the other way to do that. And for now, I'm just going to move these LEDs up here. The diodes are connected to all of the LEDs, but they're also connected to the outputs of the 4017. So for example, let's take a look at how this might look. And again, this is going to look very different from your breadboard, how your breadboard would be laid out. One of the things I don't like is that some of the part numbers are really kind of long and messy on these parts. And I probably should have mentioned this in the when we were laying out the schematic. But one of the things I can do for any of these parts, for D5, I can change the part value. Click on it in the middle. It says it has no user-defined value. And then just truncate that. Maybe make it 1N4148. Josh got a shout out there. Okay. And so I'm going to move these other diodes over, and then eventually I'll clean that up by moving the, or kind of removing some of the name there. And again, there's no hard and fast rule for where these are going. I'm just kind of getting them roughly close to where the pins are. If you want to move them up on the top and line them up kind of with the LEDs or line them up all in a row, that would be totally fine too. I tend to kind of lay things out in a little bit more of what may or may not seem like a logical order, but I also want to make it easy to assemble it, so I try not to make it too messy when I'm putting these all down here. And I'll move that one there. And just kind of straighten that out a little bit. Put that one there. Now, these other resistors, looks like it's connected to that LED, but I've also got a connection over here on this resistor. I'm going to leave that for now. The 200 ohm resistor is connected to all the LEDs. I'll just put it there for now. And again, when I'm doing this, the move button is selected. That's allowing me to move all these parts. And I'm going to move this over here, and finally the terminal block I'll move over. Now the terminal block is where the power is coming into the circuit. I'm using right click, by the way, to rotate that. And So I've got a layout here. I don't know if it's exactly what I want yet. You'd have to kind of look at the actual circuit and see how the LEDs flash to figure out how that's going to work. And I'll show you a breadboarded version of that in a little bit. But for now, we've got kind of all these parts laid out here. Now, one of the things we want to do, if you'll take a look, the bottom left corner of the circuit board is the origin, 0, 0. And if you take a look up here, it shows you the coordinates for where that is. Now, in this case, by default, it's coming up in mils, thousandths of inches. I'm more familiar with inches because I can visualize that a little bit better. So I can change that. How I'm going to change that is by simply typing, or actually I don't have to type, I can click on the grid command up here, up towards the top left corner. And I'm going to change it from mils to inches, and 0.05 inches is a good general spacing for these parts. And click OK. And now I can see that my coordinates up here on the X and Y are in inches, which will be a little bit easier for me to use. And down here is the origin. If you look at the value up here, as I move the mouse down, that's 0, 0. So we kind of use that as a reference. So I'm going to move all of these parts in one big chunk over to that area. So I'm going to group them together, click move, and move them down to the corner. Now, this space here is kind of wasted space. We'll talk more later on about optimizing layout for locations of components, but for now this is okay. But the board is way too large. We wouldn't want to waste that much board material. It'd be hard to fit this in some kind of enclosure. So if I click on the Move button on the left, and then click about in the middle of that, we can slide it over. I can do the same thing for the top and move it down here for now. You'll notice when I did that you can also skew the layers. We want to always make sure they're perpendicular, that it's a square. Almost all circuit boards, well, a majority of circuit boards are square or rectangular. Now I'm going to click the Zoom to Fit button, and now it's starting to look a little bit more like a circuit board. Now I'm going to change a couple of things here. Take a look at this diode here. You'll notice all of them are facing the same direction except for this one. And even if that doesn't seem to be like an optimized way of it being wired on the board, I'm going to make it the same direction because I'm going to try to eliminate wiring errors. One of the things you want to start thinking about at some point is, how do we want to make this board as easy to manufacture, solder the parts on as possible? And like one of the things I did here is I changed that part number to just 1-in-4-1-4-8. I'll do that for the rest of these real quickly here. Okay, so I've changed all those part numbers to 1-in-4-1-4-8. You'll notice that some of the text is overlapping here. We want to make sure again that everything is really clear when somebody's soldering it. You don't need to worry about the air wires, but I'm going to move these up a little bit so they're not running over each other so badly here. Maybe move that guy down a little bit. And we might have to adjust the overall frame of this board too when we're done. Okay, so now you have all these crisscrossed wires, and again, you don't have to worry about that. We're going to use a router to actually figure out where all those traces go. But I'm going to click Rat's Nest again, and when I do that, watch what happens to the screen here. Okay, you'll notice that it basically optimizes the location and distances of these different nets or air wires here. Okay, now one of the things, the way that this flashing circuit works, if we go back to the schematic, it's going to start with D1 over here and flash down to D10 and go back and forth. That's basically the pattern it's going to follow. Whoops, my bad. LEDs, let's try that. It's going to flash LED 3 through 8 and go back and forth. So I want to lay these out in that order, 3 through 8. So let's go back to the board here. Now you'll notice that there are other LEDs on here. If you remember from the very beginning, we have these two flashing LEDs, 1 and 2. So we don't want that as part of our pattern. But the rest of them are going to flash sequentially 3, 4, 5, 6, 7, and 8. I can also move the text of these down here so that they're not in the way, and that gives me a little bit more space to work with. The old versions of Eagle, you had to actually separate the text from the part, and it was kind of a pain, so we don't have to worry about that. Now, if you're trying to figure out exactly where these LEDs go, you want them to kind of look aligned. So what I can do is click on the grid and click display on, and what that does then is puts a grid here. And now we can count and see if it looks like things are spaced out properly. So here I've got maybe 4 or 0.2 inches between each of these, and it looks pretty even. But you want to check that, because it's one of those things where if one of your LEDs was like that and you had your board manufactured, it kind of look a little funky unless that's what you wanted it to look like. So I'm going to move that one over, and yeah, that looks pretty good. Okay, now we got some space up here on the top. I want to get rid of that. That's just wasted circuit board. So I'm going to slide this down. And in fact, what if I wanted to move all of this down a little bit? Okay, I could group not only the LEDs, but that top edge of the board and move the whole set down. And I'd probably do something like line up the text a little bit better here so things look a little bit cleaner. I spend probably about as much time cleaning up what's called the silk screen, these labels for all these parts. It's going to look kind of funky. As much time doing that as the actual board layout. It takes a lot of time to do that. Okay, so everything looks pretty good on my schematic. The terminal block where we're bringing in the power, we'd connect like a 9-volt battery. You don't want to put that in the middle of the board. You want to put it kind of close to the edge here. Okay, and I'll move that X1 out of the way. But we also want to identify what's the positive lead and the negative lead. Now, if I click on the info button up here on the top left and click on it, it'll give me a bunch of information. Now, I happen to find out that that pin is the ground pin. The other way to do that is to click on that eyeball, the show symbol, and click on it. And it lights up all those net connections. And then down in the corner, it will also say signal ground. So I know that's the ground input. And one of the very first things I'm going to do is put a label here, because I don't want to have somebody look up on a manual to figure out how to wire this up. We can put all sorts of text on here. And this is called the silkscreen layer, and we'll talk about that in more detail. However, the layer that I'm looking at, the red layer, is actually where the traces are. So if I'm going to put any text on here, I'm going to go back up here and change it to layer 21, T place, which stands for top place. So I'm going to put ground. I'm going to hit escape and change the text to, we'll say plus 9 volts here. And I could put it down here if I wanted, but I'm going to put it on kind of the side here. Now you'll notice it's not lined up very well. Let me zoom into that. Okay. The reason why is that the grid is kind of coarse. It's 0.05 inches. To change that, I can come back here and click on grid and change it to 0.025. And now I can move it so it's lined up a little bit better, as you can see there. You got to be careful though. If you make the grid too fine, it makes it a little hard to kind of move parts around. So I usually leave it at like 0.025 or 0.050. The other mistake that sometimes happens is somebody accidentally hits like 25 here, which would give you a grid of 25 inches, and then you can't move anything. So make sure when you have your grid that if it's in inches, for example, that you change it, make sure it's at 0.025 inches. Okay. So our circuit's looking pretty good here. It's not perfect. I'd probably make some changes. I might, for example, move this diode over to here to make it a little bit more consistent with the diode on the right, but it's kind of aesthetics at this point. Now, the next thing we want to do is figure out if we're going to mount this in some kind of enclosure or box. We'd probably typically have what are called standoffs that we mount the boards with. And those are basically either aluminum or plastic spacers. They're typically anywhere from 1/8 of an inch to 1/4 of an inch to 1/2 inch long. And I'm going to put 4 holes in the corners here. I'm going to actually move this out a little bit here. Can I cheat a little bit? Move it up a little bit. And then I'm going to move this whole thing down to the origin again. Like that. Whoops. There we go. If you take a look on the left-hand side, there's some other commands here we can use, and we'll go through a lot of these as we continue the class. But one of them is basically called the hole. And I'm having a little trouble finding it here because the interface looks a little different. Okay, it's right here. You have to bear with me because I've used version 7.7 for so long I forgot about it. So this is a hole, and wherever we place that, it'll drill a hole on the circuit board. It's usually for mounting holes. The typical size that I use, if we change the size here to, for example, 0.150 inches, is a standard diameter for standoffs. So I'm going to put some holes in the corner here. I'm going to have to move my LEDs. And I'm going to place them at the same kind of dimension from the insides here. In fact, what I'm going to end up doing real quick is moving the LEDs. Okay, so I cleaned up a few things here. I moved the LEDs down a little bit, spaced them out so they look even. I'm going to also put some text on here. ELTN 115. How about Connecticut Writer? If you've ever seen that show, that's the inspiration for this. Or if you're into Battlestar Galactica, the Cylons have these little lights that flash back and forth. Okay, but you can put your name, whatever other information, date. I often will put a date on a circuit board. And again, this is just introductory. We'll get into it in a lot more detail, but I just want to kind of start this so you can see what it looks like. Now, this is the coolest part of all to me. I'm going to maximize the board here. Now, in the old days, the way that they made boards is they actually had to create a photo mock-up, basically, of the board at a 4x scale and lay tape down to create the traces. Pretty old technology, and we'll be actually looking at that a little bit, how they used to actually design and fabricate boards. So there's a command here that's called route airwire. And I could come in and go, okay, I know that this has got to get connected. For example, this resistor has to get connected to this capacitor. So I'm going to click on this route airwire, and I'm going to route it like that. And I could do that for all of these connections. The problem is you can't cross anything over. So the red refers to the top layer, blue is bottom. And if I was to do this one at a time, it'd be a pretty tedious process. Now, there's some people who are pretty religious about manually routing a board. You could try to do that, but it becomes pretty tedious after a while. And especially for a simple board like this, it really is unnecessary. Let me show you why. So that command was called route airwire. I'm going to rip up these traces. The rip up command basically will get us back to all air wires, and the term comes from when they actually used to have to pull off red or blue tape off the circuit board. So I'm going to click up rip up, then I'm going to click go, click yes, and that gets us back to where we were before. So rather than do that, we're going to use the auto router. The auto router is a really powerful tool. What it does is it calculates the best optimal locations for all these traces. It tries to eliminate extra holes that are drilled in the board. And we can invoke that by clicking on this button called auto router. Now, I'm going to just briefly go over this. This is going to be super quick and dirty because I want you to just see how it works. The top, we're going to route a double-sided board. That means there will be traces on the top and bottom. So you see top up here, bottom here, and they're both set to auto. All the other layers are disabled because we're only doing a 2-layer board. And later on, we'll do some single-layer boards. But I'm going to click continue. Actually, for effort, we'll put medium. We'll make it work a little harder. And we'll click continue. And this is what's really cool. It's going to try to eliminate however all the possible holes that are drilled. Let's see how long this takes for it to route it. Now it's done already. And it's been done for a while. But this T router, the topographic router on the top, usually takes a little bit longer. I like to watch it. It's a little more fun. So I'm going to cancel that. If you click on auto router, we're going to hit continue. And I'm going to select this second one, waiting. And we'll actually get to see it try to figure out the auto routing. And it's done. It's at 100%. It actually finished it pretty quickly. What it's trying to do, though, is do some optimization. We'll talk a little bit more about what traces it's trying to optimize. But imagine if you're having to do this manually, how long that would have taken to do. A couple other things I'm going to show you real quick here. These traces are pretty thin, and we can change this by changing what's called the class of the traces. I am going to add a class here, and you have to pardon me because this is a little bit different than the way that I'm used to using. Oh, here we go. It's on the rules button. Sorry. It did change the interface a little bit here. So I'm going to call this, or for the default, let's change this. Let's change our width of our traces to 20 mils and the clearance to 20 mils. And then I'm going to create a new class called power. I'm going to change that to, let's say, 50 mils. That's quite a bit, but we'll just leave it at that. Okay. Now, you'll notice nothing changes here because anytime I make any changes, I have to rip the board up and start over. So I'm going to rip it all up by clicking Rip Up, Go, Yes, and now I'm going to route it again. And we want to watch it. And you'll notice it's done already. That's how long it took it to figure out. Traces are a lot thicker here. I can click End Job. I can look at different variations here and see which one I like for whatever reason. Sometimes they look a little bit different. But I'm going to end it. So all of these, what you're looking at here, are all these red lines here are going to be circuit board traces. Top copper traces, and the bottom are the blue ones. We cannot manufacture double-sided boards really easily at PCC. We can kind of make them using what we call the other mill. But we can do single-sided boards pretty easily. So anyway, I just want to kind of walk through basically what is involved in a route. A couple of real quick things before I sign off here. You do not want to do this. You do not want to move a part after you've routed it. As you can see, we can have crossovers and all sorts of problems. In fact, it's showing there that we've got some short circuits that would occur. So you never really want to do that. If you're ever going to move any parts, you always want to rip it all up first. And then, for example, we could rip it up. And then let's say, for example, I don't like where that capacitor is. I want to move it over, or I want to move some other part here. Maybe this LED isn't lined up exactly right. So once I'm done moving things, then I can go ahead and route it again. So we're going to go ahead and route this again and take a look and see how it looks. And it's done. The vias are basically what they are holes that are connected between the top and the bottom of the board that are not going through where the actual components are soldered in. Now, if we want to try to spot that, it's a little tricky. But if we go to View, we can turn off the top and bottom layers. And there it is. I can see it right there. That little hole is a pad, and what it does is it connects bottom traces to top traces. So if we go back to View here, go to Layer Settings, Top and Bottom, you can see, whoops, leave that on there. You can see that it couldn't figure out how to run that without actually going under the board and sneaking over here to connect to that LED. And there might have been a way to do that, but it'd be pretty complicated to try to figure it out. Okay, so that video is kind of long. Feel free to watch it 1.5 times speed like we do with lots of YouTube videos. But I just want to kind of give you a starting point, and what I'd like you to do is go ahead and start doing a layout for your board. It doesn't have to look like this, but I want you to start with this as a sample to see if you can kind of get through this process. I didn't go through a lot of the commands. I just went through the primary ones. But if you get stuck, let me know. I'm happy to work something through with you. But hopefully this video will kind of help you understand how the board is laid out. Last thing I'm going to say here, when we close out a program, we always want to make sure that the board and the schematic are closed at the same time. The problem is that if we close one without the other, we can make changes in it and we lose the connection between the two. So we haven't changed anything in the schematic. The schematic's the same. But if I accidentally tried to delete a part or something with the schematic closed, that would cause problems. Okay. So that's the end of the video, and we will continue moving on through the unit.